Welcome to readmeproject.com. Project title: A secure, efficient data collection algorithm based on self-adaptive sensing model in mobile Internet of Vehicles. Now we are going to see the abstract. Existing research on data collection using the wireless mobile vehicle network emphasizes the reliable delivery of information. However, other performance requirements such as life cycle of nodes, stability, and security are not set as primary design objectives. This makes data collection ability of vehicular nodes in real application environment inferior. By considering the features of nodes in wireless IoV, such as large scales of deployment, volatility, and long-time delay, an efficient data collection algorithm is proposed for mobile vehicle network environment. An adaptive sensing model is designed to establish vehicular data collection protocol. The protocol adapts to group management in model communication. The vehicular using node in group can adjust the network sensing chain according to sensing distance threshold with surrounding nodes. In addition, secure data collection between sensor nodes is undertaken as well. The simulation and the experimental result shows that the vehicular could realize secure and real-time data collection. Now we are going to see the flow diagram. First, the network model is created. Here, the base stations and the number of moving vehicles are created in the network. After that, according to the self-adaptive sensing model, the neighbor nodes are all found out. Then it broadcasts the messages with the help of RTS and the CTS packets. RTS is request to send, CTS is clear to send. Using this packet, the broadcast messages are forwarded. Then it forwarded to the next node in the network. If the hop is completed, means then the packet transmission is processed. That is, it finds out the route and it performs the communication. If the hop is not completed, means it broadcasts messages until it is completed. These are all processed only by a self-adaptive sensing model. Finally, the performance is analyzed, in which the proposed self-sensing model is compared with the existing approaches. Now we are going to see the output demo. First, open the terminal window, then go to the directory, then type ns space file name .tcl. This is the main command to run our code. Give enter. Now the nodes is created, and according to the self-sensing model, the nodes informations are all updated here, and the security is mentioned as with the hash function. So this is the network animator window. Here only we see the output result. To run our simulation, click on the play button. Here first the security packet is forwards its key to the destination. So only we get this like that. So these two are the towers, that is ENBs, which are connected in a wired link. These are all the vehicles that move in the location. Now the packet starts to communicate. According to the self-sensing model, these packets are communicated. So these informations, which node, which is the source node, which is the destination node, and which positions it is located, all informations are gathered by these towers. So that only we see in here. So at which time which node communicates with the destination node, which is the next hop, and how many time taken to perform the communication process, all are displayed here. So that are all sensed in this tower. So now it again the node starts to communicate. So vehicles are all moved in that area without placed in a static location. To see the performance of this, back to the terminal window and then type GNU plot dv.plot. So this is the dv graph in which the TDMA, STDMA and self-sensing model are compared. In x-axis, number of nodes are plotted and in y-axis, transmission delay is plotted. By varying the number of nodes, we have to calculate the transmission delay, that is packet transmission delay, which is measured in milliseconds. Our self-sensing proposed model has less delay than the existing systems. To see the another graph, type GNU plot THR, that is throughput.plot. This is the throughput graph. Here we vary the simulation time and find out the throughput for each and every unit time. So here TDMA, STDMA and self-sensing model are compared. So our proposed self-sensing model achieves a high delay than the existing system. The throughput are measured in megabits per second. Hence, we conclude that the performance of our proposed sensing model is increased than the existing system. That's our demo is completed now. Thank you for watching this video.